Now I am going to start the class. Good morning to all. And in the last lecture, we discussed about the diffraction. Sorry. In the last lecture, we discussed about the interference. Now I am going to explain about the diffraction topic. Okay, what is diffraction and what is interference? What is the difference between the diffraction and interference? That things we are going to discuss. Today's topic is also very important for the long answer question, and you listen very carefully. In this chapter, three questions are very important. Okay, three questions are very important, and that are very important for the long answer questions. Okay, the first one is the Young's double slit experiment. Okay, in that, what about we discussed in the Young's double slit experiment? Condition for a bright band and condition for a dark band, and how the bands will forms on the screen. That we discussed. That is the important topic. And after that, the most important topic is the diffraction. Now I'm going to start the diffraction, and in the middle, I uploaded yesterday one lecture. That is the fringe width calculation. That is also important. Fringe width derivation. I derived the last lecture. I think 10.7. Okay, 10.4 is Young's double slit experiment. Very important for the 5 marks. And the next one is the 10.7. It is the fringe width calculation. Fringe width. And that is also very important for the 5 marks. And 10.8. Okay, Today's lecture also very important for the 5 marks. These are very important in this chapter for the 5 marks. And for the 3 marks, there are two questions are there. One is reflection verification of 10.2. 10.2 lecture is important for the 2 marks question or the 3 marks question. That is the reflection and refraction of plane wavefront. Okay, and these are the important questions. And today lecture is very important, and you listen very carefully. I am going to explain the diffraction and the diffraction at the single slit. And if you have any doubt, you can ask while teaching only. You can test the message. Okay, I will try to clarify. Otherwise, after the class also you can ask through WhatsApp. Okay, and let us consider this is a slit, and this is the screen. This is a slit, and this is the screen. Okay, and for example, the source is at long distance, source is at infinite distance. The light rays coming from the source like this, and they are incidenting at the edge of the slit. This is a slit you see here. This gap, this opening is said to be slit, through that the light will passes. And when the light, we know that the light travel in the straight line path. It should go in the straight line. Actually, it should go in the straight line like this. But due to this, what you have to observe on the screen, you should observe this on the screen. You have to observe the brightness. Okay, the light is traveling in the straight line path. Previously we know that according to that, if the light travel in the straight line like this, then in this region you should get some more brightness. You have to get the brightness at here. Why? Because the light is coming like this in the parallelly, and it is an opening. Okay, what is this slit? Or it is a cardboard with opening. It's a narrow opening. Slit means cardboard with opening. Okay, and here the light will travel like this also, but this is a cardboard. It blocks the light. Light never passes through this because it is a wooden board. And here also light will travel like this in the straight, it will blocks. But here this is an opening. Through this the light will be travel in the straight, and it will passes, and this region you should get the more brightness. But in the practical observation, when the slit width is very small, and in the more region they are observing the brightness. That means instead of observing the brightness at here, okay, and you are observing the brightness at some more, okay, and some more radius and some more area you observed the brightness. Why we are observing the brightness? That means the light is not going straight at here. The light is not going straight at here. If it will goes in the straight, what happens? The brightness should be appears at here, and here the light is not passing. That's why at this region you should get the darkness. Okay, but the practical observation is that here, here also we are getting the some brightness. Here also we are getting the brightness. Actually, the light should travel in the straight. You should not get the brightness at here. Here the light is blocked. That's why light should not enter in this region. But even though it is entering, that means the here the the diffraction pattern is observed. That is, light bends like this. Cannot travel in the straight line. Light bends like this. Then this region you observe the more brightness. That means light is bending at the edge of the obstacle. This is an obstacle. You see here, this is an obstacle. This one. Obstacle means what? Okay. Obstacle means anything that is opposition to the light. That's an obstacle. Okay. And now, what is the definition of the diffraction? Here you see the light ray is not going in the straight, it is bending it here. Where it is bending? At the edge of the obstacle. At the edge of the obstacle. This phenomena is called as a diffraction. The phenomenon of bending of light at the edge of the obstacle. Obstacle means it will not allow the light. Okay. And then at the edge of the obstacle, the light is bending. This phenomena is called as a diffraction. Previously also we discussed the bending phenomena, that is refraction. When the light ray passes from one medium to another medium, it bends at the separation of two mediums. When light ray travel from one medium to another medium, it bends. That is called as refraction. If light ray travel from one medium to another medium, at that moment the bending phenomena is said to be refraction. But here the light is not traveling from one medium to another medium. The light is incidenting at the edge of the obstacle. That is called as diffraction. Okay, and due to the diffraction, here you observe the brightness in the more region. Actually, if the light travel in the straight line, you should observe the brightness in this region only. But the light is bending like this. That's why you will observe the brightness in the more region, right? That is a diffraction. I will write the definition of the diffraction. That is, a diffraction is nothing but the phenomenon of bending of light at the edge of obstacle. Phenomenon of bending of light at the edge of the obstacle is called as diffraction. Diffraction is the bending phenomena. Okay, diffraction is the bending phenomenon, the phenomenon of bending of light at the edge of the obstacle. Okay, and here if you observe this, this is the diverging beam of light after passing through this slit. Okay, this is a slit. This is a slit. When light passes through this slit, what happening at here? This light is bending. Okay, and this light is diverging at here because they are moving away from each other. Okay, and this beam, if you write the wave fronts, you will get like this. That means what happening at here, whenever plane wavefront incidenting at here, the wavefront is now incident wavefront is plane, but after passing through the slit, parallel light rays means the wavefront is in straight plane wavefront, but after passing through the slit, it will become the spherical wavefront. Okay, and this is the diffraction. Now I will give one more example for the diffraction where you will observe the diffraction. I will write here. You see very carefully, you have to listen. Okay, and you see here, this is the straight edge. Okay, diffraction at the straight edge we will discuss. It's a obstacle. It's an obstacle. It will not allow the light. It's a cardboard. Okay, it's just like wall. Okay, and it is a screen. Let us consider this is a screen. This is a screen. Okay, and now for example, this is the source of the light. It is the source of the light. We know that the light will travel in all the directions. Light will travel in all the directions, we know. This is the source of the light. And the light will travel in the straight line path. We know that the light travel in the straight line path. Like this, light will travel to the screen. In all the directions, light will travel. Here, what happens? The light rays which are incidenting on the obstacle. These two light rays are incidenting on the obstacle. They cannot pass through the obstacle. Obstacle blocks the light rays. That's why what you have to expect on the screen. On the screen, you have to expect below O, you should expect the above the O, you should expect brightness. Okay, above the O point, you should expect the brightness because the letters are incidenting it here. That's why brightness. It's a source of the light. It is a source of light. It is the source of light. It is emitting the light. And you see, and in this region, okay, practically what happens in this also, in this region you should get the shadow of the obstacle because this obstacle not allow the light to pass. That's why you should have to get the shadow and the darkness at here. But a practical observation, you should not get the complete darkness at here, and up to some region you will get the brightness. That means the light ray which is incidenting at the edge, if it goes straight like this, above O you should get the brightness, below O light rays are blocked, that's where you should get the darkness. But the practical observation, below O also we are getting some brightness. That means some light rays are entering below O. How light ray is entering below O? That is the light ray which is incidenting at the edge, it will bends like this and it will enters into the geometrical shadow. That's where here, some light rays, some brightness is occurs. Okay, for the class. Some brightness is occurs below the O. This is the bending of light. Where the light ray is bending it here at the edge of the obstacle. This bending phenomena is called as the diffraction. Okay. When what is the condition to get the diffraction? The condition to get the diffraction is condition to obtain the diffraction. Condition to obtain diffraction. Okay, the condition is that the slit width. Here we have the slit. This is slit width. The width of the slit we can take as A. Okay, and this is the slit width. This the width of slit to obtain the diffraction bending phenomena. The width of slit is comparable with the comparable with the wavelength of light. Comparable with the wavelength of light. Then diffraction occurs. means the slit width is A, it is nearly equal to the wavelength, then diffraction occurs. In diffraction, here the light rays are diffracting it here, bending in the both the cases, right? If the bending light rays are again interfere with each other, superpose with each other, then you will observe the alternative bright and dark bands. Okay, I'm going to erase this. You take the screenshot. Due to diffraction, due to diffraction, alternate bright and dark bands. Due to diffraction also, bright and dark bands are observed. Dark bands are observed on the screen. Okay, and this is about diffraction introduction. Okay, what is diffraction and when diffraction will occurs, and what is the condition to get the diffraction pattern. In diffraction pattern also we are observing the alternative bright and dark bands. Why alternative bright and dark bands appeared on the screen? What is the reason? Okay, that I am going to explain, and that is important for the long answer question. Okay, right, I am going to erase this. Right. Now I am going to start the long answer question, that is diffraction at the single slit. Diffraction at the diffraction at a single slit. Diffraction at a single slit. You listen very carefully, and this is a very important topic. Okay, you have to listen very carefully because some imagination is required for understanding. Okay, it takes the time also. You must listen very carefully. This is not easy to understand. Okay, and if you listen very carefully, and then if you will get any doubt, you can ask me, then you will understood everything. Okay, I will try. It was very simple if you will listen very carefully. This is the slit, this is the screen, and now I am taking the one plane wavefront is incidenting it here. Plane wavefront means light rays are incident parallelly like this. Light rays are incidenting parallelly. Okay, the slit width we can consider as a small a. Slit width is a, and here we will keep one lens. This is a lens, convex lens. Okay, this is the center of the slit. Okay, it is a slit. This is opening. This opening is said to be slit, and O dash is the center of the slit. You take this line. You draw a line at here from center of the slit to center of the screen. This O is the center of the screen. O is the center of the screen. And now when the light ray incident at the edge of the obstacle, okay, this is the slit. Slit edge is this one. At this edge, if the light ray incident, it will bends. Okay, and it will bend like this. It cannot go in the straight. It will bend like this incident. Here also at the second point, here one more light ray is incidenting it here. Here also it will bends. After bending, these light rays are meet at one point on the screen. These convex lens, what it will do, it will converges the light rays at one point on the screen. This is the point P where the light rays are converged with each other. And then at what angle this light ray is bends? The angle through which the light ray bends is theta. Let us consider. This is the original path. This is the original path. And the angle through which it is bends is theta. This is the diffraction angle, bending angle. Okay. And now we want to find out the path difference between the light rays which are reaching the point P. Here the light rays are meeting. Due to that, here you may get either bright or dark bands at point P. You may get either bright or dark band. Why? Because the two light rays which are bending, diffracted light rays. Here the light rays are coming parallelly. Okay, plane wavefront is incidenting it here. But after the incidenting on the lens, they are converging at point P. Due to that, at the point P, you observe either bright or dark band. Okay, at the point P, these two light rays are meeting at here. Not only at here, at every point the light rays will be meet. Light rays will meet at here also, at here also, at every point on the screen it will be meets. And if they meet, if they superpose with the path difference, okay, lambda by 2 or the phase difference pi, then the dark band will be forms. You know when the dark band will forms, when the bright band will forms. Previously in the interference we discussed. Now here, uh, let us consider something will be forms at here. Okay, and now I want to know the path difference at here. For that, what I have to do it here? I have to draw the normal at here. I have to draw the normal. Okay, this second letter, the letter which started from the second edge, the letter. For example, this point we can consider as A. This point is capital A. This edge we can consider as B. And the light ray which is reaching from B reaches the point P. The light ray which is coming from A also reaches the point B. But the light ray which is coming from B should travel long distance to reach the P, because A is near to P, but B is not nearer to P. That's well, there is a path difference is there. To find out the path difference, we have to draw the normal at here. This is A. We have to draw the normal at here. Normal to the second light ray. This is the normal. Okay. And this point we can consider as N. This point we can consider as N. And this angle from the mathematics. Okay. And this angle from the mathematics you will get as theta. From the mathematics you will get that angle as theta. And now this distance is the same now. The excess distance traveled by the second light ray is Bn. That will become the path difference. Okay. And now how to find out the how to explain the alternative bright and dark bands which are formed on the screen. For that, what we have to do it here? First, we have to write the some terms. What are the terms? O is what? O is the center of screen. O is the center of screen. Okay. And O dash is what? O dash is the midpoint of slit. Is it right? Midpoint of slit. And A is what? Small a. Small a is the width of the slit. Small a is the width of slit. And the next theta is what? Theta is the angle of diffraction or the diffracting angle. Angle of diffraction means with what angle it is bends. Okay, you have to listen very carefully. Okay, and this is the most important topic. And now, what we are doing it here, one light ray travel to point P, other light ray also travel to point P. At here, this convex lens converges the light rays meet at this point. Due to that, if the superposition is here, the two light rays are meeting at here. If the superposition is constructive, bright band forms. If superposition is destructive, dark band will forms. Okay, let us start. When it will forms the bright band, when it will forms the dark band. For that, I will write few sentences at here to explain diffraction pattern. To explain diffraction at single slit. To explain diffraction at single slit, we divide we divide slit into much smaller parts, much smaller parts, and add their contributions add their contributions at any point. We can consider it as P. At any point P, at any point P on the screen, with proper phase difference, with proper phase difference. I will explain this sentence. Actually, what he is telling that to explain the diffraction at single slit. If you want to know diffraction at single slit clearly, what we have to do? We divide the slit into much smaller parts. This is the slit. AB is the slit, right? AB is the slit. Yes, this is slit. We have to divide into smaller parts. And what we have to do? And their contribution at any point P on the screen and add their contributions. We have to divide this into smaller parts, and from one part, what happens? Light contribution is there, because this is a slit is an opening, so that light passes. That means this is slit contributing the light, and then from each part we have to get the light to point P, and then that all parts we have to add, right, with the proper phase difference, and based on that we will explain. And just in the continuation you understood every point. At the end you will get the clarity, and now you have to note every point and try to understood whatever that I am telling. And here anything will is not understanding, that you will be clear in this class only after few minutes. And then next, I want to find out the path difference. The path difference between the path difference between Light waves, path difference between light waves coming from, path difference between light waves which are coming from two edges of slits. You see here one light ray is, you see the figure. A is the one edge, B is the other edge of the slit. From the both edges, the light rays are coming. What is the path difference between the light rays? Path difference means what? Difference in the distance. This first letter travel A to P like this AP distance. Second letter travel BP distance. Then the path difference I want. Path difference. Path difference means difference in the distance. Difference in the distance. A to P travel less distance. B to P travel more distance. The difference in the distance traveled is said to be path difference. Then the path difference for that we have to go for the triangle. That is the triangle ABP you take. ABN you take. From triangle ABN sin theta you can find out. Sin theta is what? Opposite side by adjacent side. You see the triangle ABN, it's a right angle triangle. Theta opposite side is BN. BN by, we will get as opposite side by hypotenuse. BN by AB we will get. BN is equal to, we will get as AB sin theta. क्लास के बाद BN is equal to AB sin theta. BN is equal to AB sin theta we will get. What is AB at here? What is AB? AB is the slit width. I am going to rub the right side. I will explain each and every point then. Okay, right. You listen very carefully. Okay, this is the most important topic, and this is the, I feel for the students, this topic is the most hardest topic in the second year. Total in the total second year. Okay, and if you understood this, then you are the great person. I will try to make you to understood. Okay, and if you understood, it was very easy. I will explain each and every point. Till now, what I did again, I will revise also. Okay. Then Bn is equal to what you will get. Okay. Bn is equal to what you got from previous derivation. Just in the last step, we got is Bn is equal to, we got is AB sin theta you got. AB sin theta. But what is AB here? Bn is the path difference. Bn is the excess distance traveled by the second letter. Second letter travel some more distance, that is emitting from the B. It travel more distance to reach the point B. The excess distance traveled is B to N. Bn is the path difference. Okay, Bn is the path difference. Path difference we take delta x, it is equal to Bn. Yes, what is Bn? Delta x is equal to Bn, but the Bn is the AB sin theta. That is AB is what? AB is the A sin theta. Right? DNA AB is A from the figure. Here delta x is the path difference formula we got as A sin theta. And if theta is small, if theta is small, then what you will get? We write sin theta as theta only. We write sin theta as theta. Then path difference we will get as, path difference we will get as delta x is equal to A into theta we write. Okay. And now this is the equation The path difference one formula, and this is another formula. You should remember these two are the formulas for the path difference. Okay, and now I am going to explain the central maxima. Okay, at the center of the screen you will get the maxima. How you will get central maxima? How it is possible? Why we will get the central maxima? Okay, I will explain. You listen very carefully. At the center maxima will forms. How? How it will forms? You see here, if you take the center, I will take the two other light rays which are reaching the point P. Okay, and you take the dots like this. Okay, the light rays is coming like this, and straight like this it is coming, and they are meeting like this at the point P. They are meeting like this at point O. This is the center of the screen. Na? Right, you see here the letter which is coming in the straight, it is meeting it here, it is meeting it here. This light ray, how much distance travel? This light ray also travel the same distance. Means the distance traveled by this light ray and distance traveled by this light ray is same. That's because by seeing the figure only you will see straight line, bending, bending. Same distance traveled to reach the screen. That means at the center of the screen. This is the center of the screen, right? Center of screen. At the center of screen, you will get the bright band because they travel equal distance means path difference is zero. Path difference is zero. If path difference is zero, then you will get the bright band. Previously in the interference we discussed, if the path difference is zero, you will get the bright band. Okay, if the path difference, you see crest falls on the crest. This is the crest and this is the crest. Its angle is, for example, 90. Its angle is 90. The both are in the same direction. If crest falls on the crest, trough falls on the trough, phase difference will be zero. Then this is constructive. You will get the bright band. If, for example, the crest of one wave falls on the trough of another wave, this is the trough of another wave. Here this is zero and this is 180. Phase difference here is pi. 180 degree. If the phase difference is 180, you will get the dark band. Okay, if the phase difference is 0, you will get the bright band. Previously we discussed, right? And this is the constructive superposition. Crest falls on the crest. Crest. This is the destructive interference. Crest falls on the trough. Right? The phase difference is pi means dark band will forms. Phase difference 0 means bright band will forms. At the center phase difference is 0. That's because path difference is 0. Path difference is 0 means phase difference is also 0. Phase difference 0 means the bright band will forms. Okay, central maxima will forms. How? All the light rays, all the light rays, all the light rays which are reaching the all the light rays which are reaching the center of screen, center of screen have zero path difference, have zero path difference and zero phase difference. Zero phase difference. Path difference means zero means phase difference is also zero. We know relation between the path difference and phase difference also. Phase difference is also zero. Okay, having zero path difference and zero phase difference. Hence, central maxima means bright band forms at the center of screen. At the center of screen. What we are telling it here. Okay. Here the light rays which are reaching the center of the screen. You see the picture. This is the center of the screen. The letters which are reaching the center of the screen having a zero path difference. Same distance they traveled That's why the path difference 0. Path difference 0 means phase difference 0. Here we write that the line that delta x 0, path difference 0, implies the phase difference 0, phi 0. Phase difference, path difference 0 means you will get the bright band. That's all. Very simple. Right? At the center bright band, why you will get center bright band? This is the reason why you are getting. Because the path difference and phase difference 0, that's why you are getting the bright band. I will draw here the bright band. You listen very carefully. Right? How you will get the bright band at here. Okay, you see here. You will get the like this center bright band. You will get the bright band like this. This is center bright band. And the next like this. On the screen, you will observe like this. This is the center bright band. This is the center bright band. This is the center bright band. Okay, center bright band. Bright intensity is maximum. This is the first bright band. And this is the second bright. Okay, like this. Here also first bright will be there. This is the second bright. Now I am going to erase the right side. How first and second like that minimas and maximas will forms. And this is the minima. You see here. This is the first minima. Means dark band. The bright means this is the dark. First dark. This is the second dark. Okay. And this is the first dark. This is center bright. And this is the first dark. This is the second dark. What is this? Actually, you see the picture very carefully. This is the bright. Okay. Next dark, center bright, dark, bright, dark, bright, bright, dark, bright, dark, bright. Like this, alternative bright and dark bands forms on the screen. How center maxima? Center maxima means bright band, minimum means dark band will forms. Now I am going to explain how bright band will forms. First bright band and second bright band. How other dark bands will forms. That I will going to explain. On the right side, I am going to erase. Next, how minimas will forms. Okay, that I am going to explain. Okay, and further purpose, condition for minima. Okay, how minimas will forms, that I am going to explain. Other dark bands, minimum is dark bands. How dark band will forms, that I am going to explain. For the purpose, what we have to do? Yes, and we have to go for the condition for nth minima. To form nth minima, what is the condition? Directly we will write the condition and we will prove it is correct. The condition for the minimum is path difference should be equal to n lambda. This is the condition. Okay. Previously, this you took it as interference, you took it as for the condition for the bright band. But now we have to take it as for the dark band. Path difference we know previously a sin theta, that is equal to n lambda. For the nth minima, for the nth dark band, it is a condition. Directly you have to remember. If theta is small, we write sine theta as theta. Then we will get a theta is equal to n lambda. Then theta is equal to, we will get as n lambda by a. Okay. And now this is the equation 1 we can consider. Okay. What is theta at here? Theta is the angular position of nth minima. Nth minima angular position. What is the meaning of this? The meaning of this is that, for example, this is the slit and this is the screen and this is the center of the screen. Okay. For example, here nth minima forms. If here nth minima forms, this is the nth minima. Nth minima. If it is the nth minima, if you join the center of the slit with nth minima, then this nth minima is making some angle. That is the angular position of the nth minima. The angular position of the nth minima formula we got is n lambda by a. Okay, and now I want to explain how first minima forms. Okay, then the first minima side heading. First minima, how the first minima forms. Okay, first minima how forms. This is the position of the angular position of the first minima. Then nth minima angular position formula is n lambda by a. First minima means we have to write n is equal to 1. Angular position of the first minima I want to find out. If n is equal to 1, in case of first minima, n is equal to 1. If n is equal to 1, then from equation 1 we will get angular position of the first minima. First minima, what angle it will makes. When you write 1, then you will get theta is equal to lambda by a. Now I am going to erase. You should listen with patience for more 15 minutes. Don't leave the class. Finally, you will get the conclusion. Okay, and you should watch more 2 times this lecture. Then you will get the full clarity. Okay, and this is the most important, right? And you listen very carefully. First minimum angle we got. First minimum angle we got. Next, what we have to do? Let us divide. Let us divide slit into. Let us divide the slit into. Let us divide the slit into two equal halves. Two equal parts. A O dash and O dash B. Okay. Each of width A by 2. It's not 9 by 2. It is A by 2. Each of width A by 2. What I am telling that I have to divide the slit into two equal parts. This is the slit A, B. And here the midpoint you take it as O dash. And now this width is A by 2. And this width is A by 2 because complete A to B distance is A to B. You see this figure, original figure. A to B distance is A, width of the slit. We divide into half. A O dash is one part and O dash B is other part. And this part width is A by 2 and this part width is A by 2. And the light started from the first part and the light started from the second part. Okay, and like this the path difference between these two light waves I want. Path difference, one light ray started from the upper part, one light ray started from the lower part. What is the path difference between these two light rays I want? Path difference between the two light rays, I want the path difference. Path difference between two light waves. Path difference between two light waves which are reaching point P. Which are reaching point P from two parts of slits. From two parts of slits. A O dash and O dash B is delta x. I want the path difference between the two letters. What I want? These are, you see this figure. This is the figure. In this one letter coming from upper part A O dash, lower part is O dash B. From that other part, other letter is coming. These two letters are meeting at P, and I want the path difference between the two light waves which are reaching point P from the two parts of slits. Upper part, we divided the slit into two parts, upper part and lower part. Slit is the opening, from AB is the slit. In that upper part and lower part, slit is divided into two parts. Then in the two parts, one letter is coming from upper part and other letter is coming from the lower part. I want to find out the path difference between the two letters which are reaching point P from the two parts, upper parts and lower part, A O dash and O dash B. एक एक लेटर अपर पार्ट से आ रहा है ए ओ डैश से, एक लेटर लोअर पार्ट से आ रहा है, ये दोनों लेटर स्क्रीन का ऊपर में मीट हो रहा है। देन इन दोनों का बीच में पाथ डिफरेंस कितना होगा? पाथ डिफरेंस का फार्मूला क्या होता है? प्रीवियसली डिराइव्ड, इधर पाथ डिफरेंस का फार्मूला डिराइव किया। एट दिस पॉइंट वी फाइंड आउट द पाथ डिफरेंस, that is the, if the slit width is A, one letter is starting from other A edge, other letter is starting from B edge, the path difference formula we got is A theta or A sin theta. Here I want to, if the slit disturbed in the light rays is A, then the path difference is A theta. But here A by 2 theta we have to write because the path separation between the light rays is A by 2 here. That's well A by 2 into theta. A by 2 into theta we write. Okay, but what is theta at here? Theta from previous equation. Okay, theta is equal lambda by A we got, right? Theta is equal lambda by A for first minima. To explain first minima, theta formula is lambda by A. You substitute here. They will cancel. We got is part difference is lambda by 2. If part difference is lambda by 2, then what is the phase difference? Phase difference between two light waves. Two light waves is pi. Phase difference between the two light waves is pi. Part difference lambda by 2 means phase difference is pi. Therefore, first minima forms. Therefore, first minima first minima forms at P. Okay, forms at P. This is how first minima forms at P. Okay, I will explain once again this point. Okay, if at the point P, okay, first minima forms. Consider just to explain this first minima at point P. What we have to do? We have to divide the slit into two parts. Upper part A by 2, lower part A by 2 width. Then the path difference between the letters which are reaching the point P from upper part AO dash and lower part O dash B. Upper part is AO dash, lower part is O dash B. Right? One letter is starting from upper part, other letter is starting from lower part. The path difference between that two letters is we want to find out that we got is A by 2 theta formula. From where you got previously, you know the path difference formula. That is delta x is equal to A theta. When the width is A, when the width is A, we write A theta, but here A by 2 is the width. Okay, distance between the letters is A by 2. That's why we wrote A by 2 theta. We got lambda by 2 here. This theta kaha se aaya? From where we got this theta? That is from the basic equation. And minimum condition for the minimum we discussed. Condition for minimum is what? A sin theta equal to, you see equation 1. Theta is equal to n lambda by A. Angular position of the nth minima. From that n is equal to 1 you write. Then if you write n is equal to 1, you will get the angular position of the first minima, that is lambda by A. Then you will get lambda by 2. Part difference lambda by 2 means phase difference is pi. We know that one relation between the phase difference and path difference. When path difference is lambda by 2, phase difference is pi. Phase difference pi means 180 degree. Opposite phase means dark band will forms. Like this first minima is explained. I think you are getting the headache. Kindly listen it here. This topic is like this only there. It takes some more time to complete. I will explain one more time, okay, without giving the notes. At that moment, you understood clearly. This is the with the giving the notes and explanation. Okay, it is making some trouble. Okay, I will explain one more time, and this topic at the time only concept I will explain. I will not give the notes, and at that moment you will get the clarity. Okay, in one page everything if it will comes, then you will understood everything. Okay, and now some more point I will give, that is similarly first minima I explained. Similarly similarly to explain second, third, comma fourth, and so on minimas. First minima I explained how it will forms. Okay, minimas, we have to divide split into 2, 4, 6, and so on equal parts. Okay, I explained the only first minima. But if you want to know the second minima, third minima, fourth minima, how I explained the first minima? By splitting the slit into two parts. But if you want to explain the second minima, then you have to divide the slit into second is two parts is complete. To explain the first minima, I divided the slit into two parts. To explain the second minima, we have to divide the slit into four parts. Six parts, eight parts like this. Next, I am going to explain one more point. That is secondary maximas. How you will get the secondary maxima? Central maxima, after the central maxima, you will see here this is the central maxima. This is the center maxima. Okay. Then this first maxima, second maximas are called as secondary maximas. How secondary maximas will forms? That I am going to explain. For that, condition for secondary maxima, we have to write. Condition for nth maxima, nth secondary maxima. What is the condition? You have to remember. There is a path difference. This condition directly we are writing. Path difference is n plus 1 by 2 into lambda. By using this condition, we proved that finally maxima will forms. Okay, you should remember this condition. Okay, this is the path difference condition. And from this, if theta is small, we write here. Where n value we write here 1, 2, 3. Okay. If theta is small, we write sine theta is theta. Then a theta we will get as n plus 1 by 2 into lambda. I want theta from this. Theta we will get as n plus 1 by 2 into lambda by a. This is the angular position of, what is theta at here? Theta is the angular position. Theta is the, this is equation 2 at here. This theta is what? Angular position of nth मैक्सिमा. मैक्सिमा के लिए, मिनिमा के लिए प्रीवियसली आया हुआ. ओके, again I am going to erase. Thank you to all. 12 members are listening with patiently. I appreciate your patience. Really, you are good. Because just for teaching only, I am feeling uncomfortable. Because you are not at here. I am not looking your faces, even whether you are understanding or not. Even though you are really listening carefully, right? I will thanks a lot to you. Oh, again, I am going to continue. And where we are now in equation 2, angular position of nth maxima is completed. Then first maxima I want. First maxima, what we have to do it here. In case of first maxima, n we have to write 1. Then we will get the theta for the first maxima. That is previously we got n plus 1 by 2. Formula we got is n plus 1 by 2 into lambda by a. N we write 1 for the, n we write for 1 for the, previously we got n plus 1 by 2 into lambda by a for the nth minima, nth maxima. First maxima means n equal to 1 we have to write. Just this is from equation 2. Okay. And now theta is equal to, we will get as 3 lambda by 2a we will get. Okay. And now what we have to do to explain the first maxima, what I have to do it here. Okay, let us divide Let us divide it into three equal parts, each of width a by 3. Previously, you see the slit, actually slit is diagram, you see slit width is a. Three parts I am splitting, three equal parts. Each part is a by 3 width, three parts, 3 into a by 3. Here you will get. Okay. And the path difference between the light waves. Path difference. I divided the slit into three parts it here. You see here, this is the slit. Then the slit is divided into three parts. So here a by, this is one part, and this is another part, this is another part. Like these three parts I divided. Okay, total slit width is a. Total slit width is a. That is divided into three parts. Then one light ray you take from the first part. This is the one, two, three. One light ray started from first part. Another light ray started from the second part. Then what is the path difference between the two light waves? Here the width is a by 3. Here the width is a by 3. This width is a by 3. This is a by 3. This is a by 3 width. Then the path difference formula is what? Path difference previously we derived. A sin theta or a theta. But a is a by 3 here. Then we write as a by 3 into theta. Then a by 3 into theta we got as something I have to write, some more information I have to write here. Path difference between two light waves. Path difference between two light waves from path difference between two light waves originating from two adjacent parts. Originating from two adjacent parts. You see here, diagram. This is the first part and this is second part. Okay, and that two are adjacent parts. Three parts we divided, and adjacent you take one and two or anything. Okay, what is the path difference? Path difference formula is a by 3 into theta. Okay, a by 3 into theta is what? Theta we write as 3 lambda by 2a. In about just here we got. Then you cancel it. Finally, we are getting the lambda by 2. Path difference lambda by 2 means what is the phase difference? Phase difference is pi. Okay, phase difference is pi. Again, I am going to erase. It's also bored even it is not erasing. So much lagging is there. After some time it will rub. Within 2 minutes it is going to close. At the end, I think you not understood anything. Yes, myself I am getting that you not understood anything, but you are getting the notes and you write the notes everything, and later you try to read the step by step, and after first you write the notes, then after that you open the video and you start the writing, you start the listening once again, and after that what you have to do, I will explain once again with the Google Meet or anything, right, with the manual board. Okay, and then again at the moment you understood. Okay, we will never left this uh, without understanding, don't worry. Okay, I will make you to understood in anything. Now the phase difference between the two light waves you got is pi. What happening at here? The phase difference, therefore, two light waves which are reaching point P, two light waves which are reaching point P from two adjacent from two adjacent parts cancel with each other. Cancel with each other. Why? Two adjacent parts will cancel with each other because we got the phase difference as pi. That's why they will cancel with each other. But we divided the slit into three parts. In the two parts are cancelled, but there is a one part will be there. Due to that one part, it will not cancel. Then due to that one part, the maxima will forms. Okay, two adjacent parts cancel with each other. Cancel adjacent parts cancel with each other means their contribution, light contributions are cancelled. Okay, contributions of light cancel. Why? Because phase difference is pi. Due to part of slit, due to third part of slit, there is a third part is there. Due to the third part of slit, first maxima forms. Okay, first maxima forms. Like this maximas are explained. To explain other maximas, to explain second comma third comma fourth maximas, maximas, slit has to divide into equal parts. How many equal parts we have to divide? Okay, in the odd parts we have to divide, that is into 5 comma 7 9 and so on, equal respectively, right? Next, last one graph, intensity versus intensity versus intensity versus intensity versus angular position graph, intensity versus angular position graph. Angular position is taken on x-axis and intensity is taken on y-axis. Intensity is taken on y-axis. You will get the graph like this. This is at the center, bright band will forms. This is the first minima. Okay, that is the first minima. We can take it as a dark one, D1. This is the first maxima, B1. This is the second dark, D2. Okay, like this, dark and bright bands will be forms. And the angular position of these values, if you want to know the angular position, what is the angular position of the first minima? That is lambda by A. Okay, this is 2 lambda by A. Second minima, lambda by A. This is D1. This is B1. This is D2. This is B2. Okay, this is D1. This is B1. Intensity more means bright, intensity less means dark. D2, B2. Okay, right. And thank you for watching my lectures. Thanks a lot. And you first, I will give the instructions to understood this topic. First, you write the notes, and then after that, keep the notes in front of you, and once again replay from the beginning. With patiently, you can listen. And if you will get the doubt in at every point, once you listen totally with the notes and step by step. Okay, in any step, if you will get the doubt, you can contact me in the WhatsApp. And then after that, we will again, once again, I will explain this. And at that moment, you will get the clarity. And this is the most important topic. And that is also tough and it is understand. And then in this, what we have to did means how bright and dark bands will forms in the diffraction that we have to discuss. Right? And then I'm going to close it. Thank you to all.